Yes, good evening. Welcome back to another beautiful session of this control system subject concepts we are seeing actually. And in our previous session, we have seen one example on how to find out the transfer function of a given block diagram using block diagram reduction rules. And today in this presentation, I am going to solve one more example for you so that you will understand in a better way. Let us start. By the way, this is lecture number 7. Lecture number 7. So, in which today I am going to directly explain you one example. We will see one example. In this example, you have one summer point, there is a gain G1. Let us say there is another summer point, and here you have G2. Immediately after you have G3, and then this is your C of S, this is your R of S. Okay. However, the input is always plus only. This you must remember all the time. And you have one negative feedback loop here. Directly this is given like this from output of G3 to part of this one given back like this. And here for this summer you have another negative feedback here with a feedback element gain is equal to, it is H1. Okay. And you have one more feedback element is coming with positive feedback as feedback element H2. Okay. And that is in fact connected to after G2. Okay. This is given problem. For this problem, okay, you are asking that find out the overall, what is the overall transfer function, the overall transfer function, that is TF. That is your question. What is TF? What is TF? Transfer function is nothing but it is simply the ratio of output to the input. Output to the input, that is C of S by R of S. This ratio you have to find out. That is what our target. Okay, this is the given problem. Okay, now I am going to solve for this. So before going to solve this problem, this can be solved in 2 to 3 steps. This problem can be easily solved in 2 to 3 steps. Okay, carefully follow the presentation or the session. You will enjoy this lecture. Okay, so first of all, this means that you are able to see so many blocks in this given example. Okay, so for your understanding, what I can do is that just I will put in a dotted line like this, just for your understanding. I will put the entire block, means after RS, before CS, whatever is blocks are available, no, this I will mark in a dotted line. Means that what by this way, what I want to convey you is that whatever the blocks given or whatever the blocks are available in between R of S to the C of S is nothing but the content within this dotted line should be minimized, should be reduced as a single block. That means we have to simplify this problem by using the block diagram reduction rules. The number of blocks shall be reduced. How many blocks are there in this dotted line or in the given problem? This is the first block, 1, second block, third block, fourth block, fifth block. There are 5 blocks are there. Is it not? Therefore, all these 5 shall be reduced, and you should make it in such a way that so as like this, you must have only one box only. Okay, this is what, this is your R of S, this is your C of S, and this is what your transfer function means. Okay, as a single block we have to simplify this. After simplification in 2 to 3 or up to 4 steps, the resultant whatever we get, you should represent in this block, single block. The problem should be solved in a single block, as a single block. That's what we have to do. Okay, means now see that very carefully. How to reduce? This is a simple example I have considered for your better understanding, so that I want to convey how to apply the rule for any. It is very simple, or in later session we can solve little bit a bigger problem also with more number of blocks, but the rules are the same, nothing to worry. Okay, the rules are the same, only thing is we must understand how to apply the rules. Okay, here the very important point you should remember is that first of all you must observe that is there any loops, closed loops are available in the given problem. It could be positive closed loop or it could be negative closed loop. As we have seen in our second session, if you remember, okay, in closed loop we have 2 types of loops basically. That is, one loop is with positive feedback and the another loop is with the negative feedback. Either could be available in the given problem or sometimes may or may not. All the loops can be negative feedback with negative feedback, or all the loops, okay, could be with positive feedback, or sometimes positive may be there or negative may be there. Okay, but okay, now I will explain you very clearly. Now you see that this is your input from R of S. See clearly the arrow mark is going to forward direction. This is going to forward direction, and again this is the forward direction, and it is forward direction. This is forward direction. This is forward direction, going to the output as a forward direction. Means that this is the straight away. This is called one straight path from your R of S to C of S. Assume that this is your origin point, this is your destination point. Okay, if you want to reach your destination from the origin, what are the ways, what are the possible ways you have to see? Is it not? This is the direct path, means it is a direct forward path basically. That is the first thing you have to remember. The second thing is that now in control system, in the first beginning session or in the second session also, we have seen that some part of or portion of output will be given as feedback to the input. So obviously, if you see here in this problem, here see there are two from the part of the output we have taken here one feedback. Through feedback I have given to this summing point. This is whatever summing point. Okay, this is summing point, which I already explained you in the previous session. These are called summing point. Okay, similarly these points you are able to see, these are called take off points. Okay, then now so considering to this problem, portion of output fed back directly to the summer. Okay, how it is given, with positive feedback or negative feedback? Obviously, if you see this part of output is given in which direction? It is coming reverse, in opposite direction, means this is forward path. Actually from the forward path means the arrow mark is in forward direction. Part of output I have taken and I am again giving back as a feedback with the arrow mark, reverse arrow mark. It is coming like this. Actually means what? This is one loop is forming here, is it not? So this part of output, this is coming to the summing point and again this is going forward direction, means you have one loop here. This is one loop. Consider this as one loop. This is one loop. Secondly, portion of output, again from here portion of output is given, okay, back as a feedback through the gain H1 to this summer point with sign negative, means it is a negative feedback loop. And again this is also negative feedback loop. This is called negative feedback loop. And the second one is also, again it is forward direction only. Okay, from this output, portion of the output we have taken and we are feeding back to this feedback element and giving to the summer with the negative, means it is a negative feedback loop. Okay, clear? So it is coming to the summer, again it is the signal is going forward direction, again like this it will move in this way, in this direction. That is the second loop. Now is there any other loop you can able to see in this problem? Obviously here you can see after G2, after the block G2 you have takeoff point. From there this is again output only, output of G2. So the output of G2 nothing but whatever the output comes, whatever the available thing after G2 we can consider it as output. So the output of G2 fed back to this summer with the positive sign. Positive means it is a positive feedback loop. Clear? So there are three loops. Again this is a loop again because now it is coming backward direction, and from this summer point the signal is going to forward direction. It is forward, it is going to forward. From this forward I have taken part of the output of this one, I am feeding back to this summer again with positive signal. That means I am forming again another loop here. This is a small loop, nothing but it is a feedback loop. What type of feedback it is? Positive feedback, because the feedback is given with the positive sign. Therefore there are totally how many loops are there? There are three loops are there in this problem, is it not? This is the first loop with negative feedback. This is the second loop with negative feedback again. Okay, there are two negative feedback loops and this is with positive feedback. Clear? Right, very good. Then the next very important point to remember is that how to solve this problem, how to start the first step. How to start the first step means that remember that the basic fundamental in solving the block diagram reduction problems, especially on this particular concept, is that always, now see, there are three loops. Obviously this is called the external feedback loop. In any problem, not only in this particular problem, you consider any problem, in that given problem, the outermost loop is nothing but the you means that you have to simplify the outermost loop at later stage. In the final step you have to simplify this. Means that what you have to consider, you have to simplify first the internal loops of which are there in between within that external loop. Means this is your external feedback loop. External means outermost, the bigger one. I can say, what I mean is that, so this is your outermost. So these are called inner. The remaining two loops are there. No, this is one loop. These are the inner loops. These are the outer loop. Think like that. Then directly you should not go for this bigger one. It makes the problem very complex, and that is not the way also. So first of all you have to simplify the internal loops first, and then the internal blocks will be simplified, and finally the external will be remain. Then it is very easy to simplify and to get the transfer function of that given any type of problem. Clear? That you should remember. Don't attempt with the external feedback, means the outermost feedback. Don't try with that. Always focus on the internal one. Simplify the loops in such a way that how these internal should be simplified. Also, that is one point that we have to consider and we have to simplify. Okay. Therefore, as per that statement, I will not touch this loop now. In the first step, I will not touch this loop. Okay, I will think about the internal loops. Therefore, you consider, you focus up to this portion only. You focus up to this portion only. Okay, because two loops are there here. Two loops are there. Now, what is the now what I shall do now? So very clearly see this. If you able to see here, this is a summing point. For this summing point, these two feedback loops, this is one loop, this is another loop. Two feedback loops are given to a single summer point. Okay, then the summer can be splitted into 2 or 3. That is also one of the rule, which actually I have not covered in the second session. Only I have focused on the different combination of the takeoff point as well as the summing point. Means shifting of summing point either after the block or before the block. Similarly, shifting of your takeoff point after the block or before the block. Okay, there are 4 combination, no? And then elimination of positive feedback loop we have seen. Similarly, elimination of negative feedback loop we have seen. Clear? Now, this is another new rule which I am going to explain in this presentation. New rule is nothing but splitting of summing point. The summing point can be splitted as per the convenient. How to split? How to split? Okay, so this is very simple. Very simple. Okay, very simple. Means this summing point you are able to see now, and I can split in such a way that I can draw another summing point here. One feedback will be given to that, and this will be remains here. That's all. Splitting nothing but, see, I will explain you here. After that, in next step, I will solve for you. Means how this can be splitted. Means this is a summing point is there, no? This is one feedback with positive feedback is coming. Similarly, here this is always positive. This is input, no? That is always. This is with negative feedback. This is summing point. Actually, whatever is there, I am explaining here for your understanding. This implies. What? How? Means this can be splitted. This is nothing but splitting of summing point. How? Means this is your input R of S. Is it not? Whatever it is, maybe not necessarily R of S. R of S is here.